Hello everyone and welcome to my channel Codon 3 and today we are again back with the topic Combustion and Flame for the grade 8 students, and this is going to be a chapter for the revision point of view where we are going to revise the whole chapter in one shot. So most probably my criteria and my motto for creation of this video is that you can revise, or I should make it you revise the whole chapter. Yes, thank you. I should make you revise the whole chapter within 20 or 30 minutes of a video. So as you can see that there are different topics related with this chapter, and we are going to cover all four topics and the subtopics of this chapter. First, it is going to be what is combustion, and then how do we control fire. The 4.3 is going to be types of combustion. 4.4 and 4.5 I have included both the subtopics in the same category, that is the flame and the structure of the flame. The sixth topic, that what is going to be what is fuel, and 4.7 is fuel efficiency. Although there are some topics by the end, what are the hazards or what are the drawbacks of burning those fuels and how it is going to impact the environment, that is I have left for your self-study. So without being delay or without being late, let's start with the first topic, that is what is combustion. So when we go into the detail of what is combustion, so basically combustion is a process. Let me choose a pen. Yes. Combustion is a chemical process which is in which a substance reacts with the oxygen to give off the heat, and the process is called combustion. Why combustion is considered to be a chemical process? As we know that there are different types of reaction in which the chemical process are irreversible process and a new product is formed. So whenever there is a combustion taking place, always a new product will be formed, and it is a non-reversible process. Second, the substance that undergoes the combustion is said to be combustible substances, and it is called fuel. So any substance that we are considering for the combustion part, it is called combustible substances, and they basically act as a fuel. And the lowest temperature at which for fuel, this is a category of all the substances. Probably you will come to know that anything that exists in nature can catch fire. So can everything be considered as a fuel? The answer is no. So there is a definition, or there is a keyword that is used for the combustible substances to be considered as a fuel, and that is what is called ignition temperature. The fuel, its ignition temperature should be very low. It should catch fire at very low temperature. What if we start using iron nail as a fuel? So it will itself will require that much of energy, that much of heat to be burned and to be used as a fuel. So for this, the combustible substances, the fuel must have the low ignition temperature. And then what is the ignition temperature? The lowest temperature at which the substance catch fire, and it is called ignition temperature. This will be discussed later when we will be discussing about the efficiency of a fuel. That we will discuss it later in a detail. So there are three subtopics related with what is combustion. First, it is a chemical process. Second, the substances which is used for the combustion, it is called combustible substances and known as fuel. And for fuel, there must be a low ignition temperature, which is called the temperature at which it can catch fire. Now, coming to a point where we have to use the lowest temperature or ignition temperature. What we have to look for? Ignition temperature. Let me have this pointer. Yes. The substance which has a very low ignition temperature and can easily catch fire with the flame, it is called inflammable substances. That, for example, if you are talking about the petrol, alcohol, liquefied petroleum gases, LPGs, so those all substances which has a very low ignition temperature and it can catch fire, they are called inflammable substances. The example of these inflammable substances has been mentioned here. So you will find, when I'm discussing all these slides, you will find that when you will turn the pages of NCERT, you are going to find that these all things have been mentioned in the NCERT only. After this, the 4.1 is completed. Now we are coming to the 4.2 topic, that how can we control the fire. There are different factors to catch a fire in a substance. What are those factors? So we are going to discuss it here. What are those factors? You have learned that there are 3 essential requirements for producing the fire. Can you list these environments? 3 environments that is required for any substance to catch fire. Just think about it. That has already been mentioned or discussed in the class, but I am telling you here, these are the fuel. The substances are fuel, air and heat. Heat that is raised to a temperature of a fuel beyond the ignition temperature. So if I'm talking about, if a ignition temperature of a substance is probably 40 degrees centigrade, if you are raising a temperature above 40 degrees centigrade, then certainly it is going to catch fire. So then how we are going to control these fire part? So by cutting off any 3, the job of a fire extinguisher is to cut off the supply of air or to bring down the temperature of a fuel, or both. So when we try to control the fire, we know that there are 3 factors which are required to catch fire, that is fuel, air supply and the heat. Then to control the fire, we need to stop the air supply or to bring down the temperature below the ignition point. You might have seen that we are not considering the fuel part to control the fire. Suppose in a building, if a fire takes place or fire catches a building, then the whole building working as a fuel. So how you are going to cut off the fuel? This is what is mentioned in the NCERT although, but if you are talking about the fire caught into the LPG or fire caught into the petroleum, you cannot reduce down the amount of petroleum that we should take out. Suppose 10 liter petroleum has caught the fire, then you cannot remove out 8 liter of the petrol so that only 2 liter can burn. So it's very difficult, it's very risky. Later you will come to know. So that is why we are cutting off the air and bringing down the temperature are the 2 main criteria to control the fire. So this is how we are through with 4.2 topic. The next topic that we are going to study, those students who were in the class and saying that, sir, this is one of the most difficult chapter that we have gone through. Now you must be feeling that how easy this chapter is to go through. Since we have studied what is combustion and how we are going to control the fire, the next topic that we are about to start is types of combustion. So types of combustion can be of different types. We find that the gas burns rapidly and produce heat and light. And such kind of combustion known as the rapid combustion. Rapid combustion does mean that the pace of catching fire is very high. And mostly it happens in 2 types of substances. Either the fuel is in gaseous form, and it has the tendency to get converted into gaseous form or vaporize very easily. So first type of combustion is rapid combustion, where the gas or the fuel burns very rapidly and they produce heat and light. The second type of combustion, in which the material suddenly bursts into the flames without the application of any apparent cause. What is apparent cause mean here? That we are not setting up the fire, we are not making any friction things, and we are not trying to raise the temperature. It's already a natural phenomena to catch fire in those substances. For example, you have discussed so many times, that is white phosphorus. So in white phosphorus, keeping it at the low temperature such as the room temperature, it can easily catch fire, and that is what is called spontaneous combustion. The takeout from here, and I have already mentioned this thing, that a spontaneous combustion, it has been said that success is not the result of a spontaneous combustion. For that, you will have to set yourself fire. Okay? And setting yourself fire does mean that you have to really work hard. When a cracker, the third type of combustion is when a cracker is ignited, sudden reaction takes place. I'm just trying to underline those areas which you have to pay at the most attention towards. Sudden reaction takes place with the evolution of heat, light and sound, and this kind of combustion it is called explosion. So once again, burns rapidly gases, the fuel either being in a gaseous form or they have the tendency to get vaporized or converted into the gaseous form. Those type of combustion is called a rapid combustion. Second, where no apparent cause is required, it can catch fire by itself, that is what is called a spontaneous combustion. And third one is the explosion. So thereby there are three types of combustion. 4.3 is done. Coming to the next point, let me erase the extra lines that we have drawn, and coming to the next point, let me switch it off. Yes. For the flame and the structure of flame, this is only a diagram that you have to study for the examination point of view, which is having the three zones. Suppose this is a candle which is burning, and there are the three zones of the candle. The one is the innermost zone, where whenever there is a formation of flame, there is a conversion of fuel into the gaseous form. The innermost zone of the flame, it is basically responsible for the conversion of fuel in vapor phase. Means if wax is working as a fuel, then innermost zone, the wax is getting converted, liquefied and getting converted into vapor. Suddenly the innermost zone is not having the sufficient amount of oxygen, so here the incomplete combustion will take place. Certainly the temperature will be high or low. Temperature will be certainly low because there is an incomplete combustion. As we move towards the middle zone is basically responsible for production of or gain of oxygen. Certainly the temperature is a bit higher in the middle zone, and in outermost zone there is a maximum amount of outer zone, the maximum amount of oxygen is there. So that is why it will be the hottest zone. As there is a complete combustion going on. There is a complete combustion going on. So here is the flame and the structure of flame. We are done with that. Please rewind back and try to understand these things again and again when you are trying to revise the things. Now, apart from all these things, there is one more discussion about the fuel. Anything that is the source of heat and energy for the domestic and industrial purposes, anything which is having low combustion ignition point, it can be burnt at a very low temperature and it can produce sufficient amount of heat and energy. That is what that can be considered as a fuel. So if you are considering about the fuel, the source of heat energy for the domestic and industrial purposes, the mainly wood, charcoal, petrol and kerosene, they act as a fuel. So these substances are called fuel. A good fuel is one of the most readily available and it is cheap. Then you will be asked that what is the definition of an ideal fuel. So the substances which are cheap, readily available and it is very cheap. It burns easily in the air at a moderate rate. Moderate rate means it should not be it should not be rapid combustion. Moderate rate means it should be slow. If I tell you with two examples that I have already discussed in the class, that if you will burn 250 grams of phosphorus and 250 grams of petrol or LPG, suppose. So 250 grams of LPG will make you enabled to cook your food for a whole day. But 250 grams of phosphorus will take hardly 30 seconds to burn. So which is more rapid? Obviously the white phosphorus one. Can it be used as a fuel? Of course it is. It cannot be used as a fuel. So here the moderate rate means that it should burn slow and it should give you that long time. It should take a long time to provide you the energy. It produces a large amount of heat. It does not leave behind any undesirable substances. But apart from all these discussion, we can come to a conclusion that none of the fuel can be considered as an ideal fuel. So apart from all these property, one of the fuel is it will keep on missing one of the part, even though it is a very ideal slow rate, but it is not cheap. Some of the fuels are very cheap, but it is not readily available. If I talk about the two different considerations right now in 2023, I'm mentioning the time just because in the coming future, you might see these fuels available there. But after a few days back or few months back, the CNG was not available in the Bihar. So it is cheap, it is very efficient, but it is not available. So it cannot be an ideal fuel for the Bihar person. So this is all about the fuel. So can we ask that can you consider any fuel to be ideal? No, none of the fuel can be considered as an ideal fuel because it may lose some of its characteristics: cheap, readily available, moderately burning the fuel with the moderate rate. It can miss one of the few points that you can go through it, that how you are going to understand this one. And certainly this is going to be the last topic, that is what is called fuel efficiency. This is what we have to learn about that. This is going to help you in the higher classes to learn what is fuel efficiency and all. So amount of the heat energy that is produced by complete combustion of 1 kg, complete combustion of, let me zoom it out. The amount of heat energy produced on complete combustion of 1 kg of fuel, it is called calorific value. What is the unit for calorific energy? If you are using kilogram, obviously kilocalorie will be the energy. If energy is being produced by per kg, then you can easily see that what should be the unit for the calorific value. It is kilocalorie or kilojoule per kg. Kilocalorie / kilojoule. Kilojoule, kg. Now, how you are going to understand the calorific value of a particular substance? Suppose you need to boil water, and I am giving you 3 types of fuels. One is simple coal, charcoal or anything. One I am giving you cow dung, and third one I am giving you the LPG. Which one is going to burn or which one is going to boil the water in a faster way? Obviously, I am not comparing in between the charcoal and the cow dung. Certainly, your answer will be coming that the water that is using the LPG to get boiled will get boiled. That is going to take the lesser time. Why? Your answer should be that LPG is capable of producing higher amount of energy in a same amount of LPG. So this is how we are going to define that. If you will burn 1 kg of LPG, 1 kg of cow dung, cake, and 1 kg of charcoal or a koila. So the highest amount of energy that is being produced is by the LPG. And this is how we are defining the calorific value. So we can say here that the calorific value per kg, kilojoule per kg is highest for LPG. That is why it is having a highest calorific value. You can go through the NCERT. There is a chart given there that which of the fuel have the higher or different types of fuels and different types of fuel, and their calorific value is already given in the NCERT. So we have taken hardly 19 minutes and we are through with the chapter number Combustion and Flame of grade 8. Hopefully you have understood that. If you are not being able to understand any kind of topic and subtopic that we are trying to discuss here, you can go through into comment section and ask that what you have not understood. As you can go into the keywords that is for the chapter, that is acid rain, calorific value, combustion, deforestation, that is I said that you have to do it by yourself, explosion, type of combustion, flame, fire extinguisher, what are the 3 parameters that it has to consider? Out of 3, it is controlling 2. Fuel efficiency, global warming, you have to do it by yourself. Ideal fuel, ignition, temperature, inflammable, and substances. These are the keywords that you must know when you are done with this chapter. Hopefully you have liked the video. So if you are through with your doubts and discussions, keep sharing and keep liking the video. Till the time we are next with the next topic, just wait for it. Thank you.